Okay, these are the notes for Algebra 3, Section 1.3, Models and Applications. So in this course, we do some word problems, and so we're going to start out with just some very basic ones and help you learn to set them up. So my advice is always to read the problem carefully. Write any expression you need, and using a variable for x, or you might use a variable p for pay, or a t for time, or a variable that means something. You're going to write the equation in terms of the variable, solve the equation, answer the problem's question. And that's important that you do that. Go back and read the question and make sure you're answering the question. Just solving an equation, sometimes it's not enough. And then check the solution. One of the most advantageous things I think somebody has is common sense. So when you get a solution, does it make sense that that really would happen? So the first example I have, you inherited $5,000 with a stipulation that for the first year the money had to be invested in two funds, paying 9% interest and 11% annual interest. How much did you invest at each rate if the local interest earned for the year was $487? So this is a good question. And this is the skills that you need for this truly are Algebra 1, but you've just probably not seen a problem presented this way before. So the first thing I want to do is I want to pick some variables. I'm going to define them. So the first variable I'm going to pick is I'm going to say x is going to equal the money I invested at 9%, because I don't know how much I invested. So that's why it's a variable. And I want another variable to represent the money invested at 11%. So just out of habit, I'm going to pick a y. And I define these variables so that anybody looking back at this can figure it out. I know that the total money I inherited was $5,000. So I know total of my money invested at 9% and my money invested at 11% is $5,000. So I'm going to put x plus y equals $5,000. If I invest 9% x amount of money at 9%, it's going to be 9%, so 0.09 times x, and 11%, so 0.11 multiplied by 11, or 0.11 multiplied by y, and my total interest is going to be $487. So this is my total interest, but I don't know how much I invested at 9% and how much I invested at 11%. So this is basically a system of equations. I have this equation here with two variables. I have this equation here with two variables. In Algebra 1, you would have used substitution or elimination to solve these. And you could do it graphically as well. I'm going to go ahead and do substitution. So I'm going to take this first equation, and I can either solve for x or y, but I'm going to go ahead and solve for y. So I have y is equal to 5,000 minus x. And I'm going to take this 5,000 minus x and substitute it into this equation for y. So 0.09x plus 0.11, we substitute for y with 5,000 minus x equals 487. I'm going to go ahead and solve this for x. So 0.09x plus 0.11 times 5,000 is 550. Minus 0.11x equals 487. I'm going to subtract 550 from the other side, and I get negative 63. Combine a positive 0.9x and a negative 0.11x is negative 0.02x. Divide by negative 0.2, and I get x is equal to 3150. If I take that 3150, plug it back in here for x, I'm going to get y is equal to 5,000 minus 3150. So y is going to equal, let me go ahead and write that down. So y is going to equal 1850. So then I go back, it says, how much do you invest at each rate if the total interest earned? So I want to know how much I invest at each rate. So I'm going to invest 3150 at 9%. And I'm going to invest 1850 at 11%. And that does make sense. I would double check it by saying, okay, do these two add up to be 487? All right, do these two add up to be 5,000? If I multiply 3150 times 9% and 1850 times 11%, do they add up to 487? So that's one type of problem. The other type of problem I have shown here, it's one that we'll probably see often in here. So I have a rectangular basketball court. So I'm just going to go ahead and draw a picture. I don't need to have artistic skills. I'm just going to have a rectangle. So the basketball court is 40 feet more, the length of the basketball court is 40 feet more than the width. So if this is my width, and this is my width, my length is going to equal the width plus 44. And it's a rectangle, so parallel sides have the same measurements. The perimeter of a basketball court is 288 feet. So what are its dimensions? Well, the perimeter means I'm going to add all these sides. So I'm going to have W plus L plus W plus L. It's going to equal 288. I replace the L with W plus 44. So W plus 44 plus W plus W plus 44 is equal to 288. So now I've got 4 W's plus 88 equals 288. Subtract 88, I get 4W is equal to 200. Divide by 4, I get W is equal to 50. And if W equals 50 feet, and L is going to be 50 plus 44 feet, so L is going to equal 94. So my dimensions are going to be 50 feet width by 94 feet length. Okay, on the back for the notes, the other useful skill that I like to work on in Algebra 3 is solving an equation. It's called a literal equation. We're going to solve for a variable, but there's more than one variable. And there's many reasons to need to do this. In science classes or a job that you might have in the future, you might have a lot of different variables, but you only need to solve it for one. So I've chosen a couple different formulas that we're going to use frequently in here for the first one. This is a formula for calculating amount for compounded interest. So A is going to represent account balance. And we'll spend more time on this later on. But it's going to be a formula you'll be familiar with. So it's how much you would end up. If you were to deposit money into a savings account and it collects interest, A would be how much money you have in the account after so much time. P is going to represent the principal. It's how much money you start with. So it's the amount at the beginning. R is going to be your interest rate. And it's going to be a decimal. So if interest rate is 3%, the decimal you're going to use is 0.03. And T is going to equal time. This equation right now is solved for A, but I could solve it for P, I could solve it for E, I could solve it for R, and I could solve it for T. And you don't know this yet, but E is not a variable. E is actually a constant, but we'll talk about that later. So for right now, we're just going to solve for P. So if I have A equals P, E, R, T, and I want to solve for P, I have to think how these are connected. P is being connected to the E, to the RT power by multiplication. So I'm going to go ahead and divide. So I get P is equal to A over E to the RT. I could solve for R and I could solve for T, but we'll wait for that for later after we do exponents and logarithms. That's going to be my answer. This next formula is one you should have seen in geometry, but most people don't remember it. This is going to be the formula for the area of a trapezoid. So if I have A is going to represent area, H is going to be your height. A is going to be one of the bases of the trapezoid, and B is going to be the other base. And if you were to draw a trapezoid, if I wanted to get the area of that shape, the height would be the altitude that goes from one base to the other, so this is going to make a right angle. The base could be the length of this one, I'll call that one A, and the base of this is B. So if you have all those values, you could find the area of a trapezoid. If I want to take this formula and solve for H, I'm going to write the formula again and understand that I want to get H by itself. So the first thing I have is this 1/2 is being multiplied by the H. So I want to get rid of that first, and I would divide by the 1/2. But I've always been taught, instead of dividing by a fraction, I'm going to multiply by the reciprocal. So I'm going to multiply by 2/1. So I get 2A equals H, A plus B. And keeping in mind, I want to solve for H. So now I have this A plus B. That whole thing, A plus B, is being multiplied by H. So I could divide by A plus B. So I get H is equal to 2A over A plus B. I might also want to take that same equation, instead of solving for H, maybe I'd want to solve for A. So I start out with the same thing I had before. I'm going to go ahead and get rid of the 1/2. But now I'm going to go ahead and I want to keep the A here. I want to get rid of the H. So these are being multiplied. I'm going to divide by H. So I have 2A over H equals A plus B. And now I just want to get A by itself. A and B are connected by addition, so I'm going to subtract the B, and I get 2A over H minus B equals A. And I'm just going to write it with the A on the left-hand side. That's my final answer.